Raise your hand. Hi, Mari. What's inertia?
An object that doesn't ability to resist change in motion.
Okay. All objects have an ability to resist a change in motion. Do some things resist a change in motion more than other things?
Yes.
Okay. What resists more?
Heavy.
A what?
Heavy stuff.
Oh, I think you said
Stuff with
honey.
Yeah. Nice.
Honey resists change in motion because it's viscous. Yeah. Heavy things resist a change in motion a lot more than lighter things, and you guys probably experience this on an everyday basis. Okay? So Newton's first law of motion then could also be stated as the law of inertia. Okay. I think I turned this on. I don't know why I'm going back here. Second law. Mr. Newton's second law. The law of accelerated motion.
Where's my pen?
Where you left it last?
I don't know.
Grandma, I lost my pencil too.
Don't make me a pencil. Stop. That's so rude.
Hey, did you see the thunder?
I want to give him a pencil so he
Oh,
opens it.
Mari took my pencil. That would make sense.
Here we go. Second law. So we have the first law, which is called law of inertia. The second law is the law of accelerated motion. And I've already alluded to what this law is. It's the Fermat law.
What?
It's the force equals a mass times acceleration law. The Fermat law.
The
What?
flamingo.
Okay.
Yeah. Wait, what color? Is that black?
I'm not even hungry. I ate too much candy already.
I'm so hungry. I need
I'm hungry
food.
for like Mr. Murphy gave us pieces
Can I
of
get a blue
pizza.
one?
Why?
We had to buy for $1.
in there.
I bought them. Yeah, I guess it was.
Or Starburst.
No.
Our Starburst.
I don't know what's blue.
I can't change the color.
I don't know how our markers would
I'd be
be for
deceitful if
you.
that wasn't
Way better
blue.
than my colored pencils that I had to use because Sydney forgot mine.
Oh.
That's it. I'm not getting any more pencils. We're wasting time.
What? You know, she would have to forget.
Okay. So this law states pretty straightforward that there's a relationship between force, mass, and acceleration. We're going to talk about what each of these relationships are, like how force and mass are related, how acceleration and mass are related, and how force and acceleration are related. Are they directly related? Are they inversely related? And we have also talked about those relationships, correct? What does directly related mean? Come on!
Oh, the ratio is.
What does directly related
Wait,
mean?
is that?
Brother.
Hold up, I'll look it up.
Get my vocab.
Please, look at your notes.
Yes. One value.
One value goes up, the other one.
Yeah. Directly related means two variables do the same thing. So when one variable goes up, the other variable goes up. Or when one variable goes down, the other variable goes down. I showed this yesterday with a couple like random math examples, right? Didn't I? I had like 4 times 2 equals 8, or no, 4 divided by 2 equals, I don't remember, but I put it up there. Okay? I can do it again, but it didn't seem to work the first time, so. Okay? Directly related, when one goes up, the other goes up. Inversely related is opposites. Directly, same, inverse, opposites. Yes.
Oh. Wow, that was
If you know what directly proportional is. Yeah, you could summarize this by saying force is directly proportional to acceleration. This should make sense. Bigger force means you're going to
Bigger the subject.
Yeah, you can accelerate more. Little force means you're going to accelerate less. Okay? So when I say directly related, they could both go up, but they could also both go down. Directly means same. Does the same thing. Now it's important that mass is constant here, right? Because you can't have changing masses and say this. Okay, because we know that mass does have an effect. Okay? We'll kind of breeze through this stuff. Got it? Can I move on? Oh, there it is. It says it's a direct relationship. Put that in. Got it? Alright. Here you go. Mari! Being a distraction. I will keep you during lunch. I will keep everybody during lunch.
Oh,
That's
everybody's.
Yeah.
Can we stay in here? The silent ball finally.
No.
I want
Silent pizza. Alright, so what did he say? Okay. Now, this should make sense, I'm hoping, from everyday experience. Okay? If you increase the force, the acceleration increases. This is why when you drive around in a more powerful engine, an engine that can give more force, you're likely to accelerate faster. Right?
Yes.
Or if you drive around grandma's old 1932 Chevy, you might not accelerate very fast. Or if you're like me, you drive around an old Kia Spectra, which is like slower, I could probably run faster. Anyways. Didn't get it? Am I going too fast?
No.
Oh, hold up.
I'm going real
Where
fast.
would you go? I see you there.
You were messing around with pens
I
forever.
was-
Oh.
I can't write if I don't have a pen.
Let's just be honest, I like Audrey more than you.
Oh.
Leave that place.
Did you not get it too, Carly?
I don't know how long it was up there, but.
I got
You made Kamari.
I don't get it.
You made Kamari sad.
Ow!
Okay.
You guys are in one of those moods today, aren't you?
You got me sugar!
Yeah.
I
You had sugar?
don't need candy, so it's not sugar.
You obviously know.
You
You
got a
had
Valentine's Day
I
basket?
need some candies.
I didn't get a
You want some
Valentine's Day
candy?
Hey, is there a bunker going there?
You got Skittles?
Can I have it?
I'm hoping that that'll make your day better.
Oh, she got
You're
stuff.
lucky you got Skittles. No one else
Little,
got Skittles
friend-
whatsoever.
Yes, I did, Johnny.
Can I have something? Because I didn't get a basket.
Johnny, I got two, so I'll give you one.
No, it's okay. I'll go take some candy from you. I'll take candy from you.
You haven't given me chips yet. I'm not giving you nothing.
I don't remember. When I'm ungrounded, I'll have Carly remind me because I'm dead.
Ungrounded? Is that what you said?
I am grounded right now. I am grounded.
What'd you do, Johnny?
He lied.
I didn't do anything.
Now you're lying about
This is not a very productive day, ladies and gentlemen.
All Kamari.
It is all tomorrow. So it's all your fault, Kamari. I have to have you get out of the room and miss today's lesson so that everybody else can actually have an enjoyable class experience.
This is enjoyable.
This is enjoyable.
A learning class experience. Okay, here we go. Now it says if the mass of the object increases, as long as the force stays the same, then the acceleration is going to go down. This is the inertia idea. Bigger mass, less it will accelerate. Okay? So a common everyday thing that you might experience. Oh shoot, go ahead and do this. I always forget that last one. Now, why is this inverse?
Because mass goes up and then other.
Opposites. Yep.
Oh, I get it. Yeah.
Now it's important that we're talking constant force. So like I gotta have like 2 trucks with the same engines, type of thing. And I'll show you what I mean. Oh, there you go. There's your definition of what inverse means.
Can we relax it just for 1 second?
Oh, you really
Testing
showing
my patience.
now.
Okay, thank you.
Really showing favoritism.
It's okay, come on. It's okay. No, you can't.
Well, I chose it not to.
Yeah,
I need one.
So I'll take your basket.
You can have one.
I can. Oh well, I can, but I choose not to.
Why are you going on a diet?
I wouldn't call it a diet. I would call it a trying to be
Cleanse.
healthier. I don't really need, like most people think of diet as in losing weight. I don't really just want to be healthier.
So a healthier.
Sure. I don't want to die of cancer.
Yeah, that was
From that popcorn.
Here's Bill. Everybody from last year gets it.
I don't
Okay.
get it.
Can I move now?
No, yes.
So
Oh my.
Oh stop! You were one. Now listen. Listen. I know I'm kind of going through some of this relatively fast, but is this overly difficult material?
No.
Okay? Inverse, opposites, direct, same. Force, when force goes up, what's going to happen? Okay?
Go down.
Right. So, we talked about the force acceleration relationship. Here's the mass acceleration relationship, which again, this is really the inertia relationship. If I have 2 trucks with the same force, same engine, and I have one truck that has a load in it and one truck that doesn't have a load in it, you can imagine that the one with the load is going to have a smaller acceleration. Right, this is really the inertia idea. So again, I'm not going to elaborate on this overly as well, or more than necessary. Since we kind of got a slow start today, I'll make sure we get to some other things. Questions so far? Anything you want to ask a question about?
No.
Hey, stop. Do you need to put this in?
No.
No.
Why do I say that?
Because it's really obvious.
Well, was it obvious a couple of weeks ago? Maybe not. But have we hit on this pretty hard?
Yes.
Okay? So if you have no net force, you're not accelerating. Does that mean you're always stopped?
No.
What do you mean?
Constant speed.
Oh, so you could be going at constant speed, or you could be stopped. One of the two.
Yeah.
Okay.
Good job.
All right. Newton's third law.
I can get a weapon. I've got 2 weapons.
Three.
We've
got 3 weapons. Scalpel.
He's got like weapons all over his
I'll go safe anymore. Where's the sword, dear Moira?
Okay.
What?
That's the sword. That's scary.
I didn't know what it was.
I'm trying to think. Of the 3 laws, which one was probably the least familiar to you?
The fourth.
The second one, the one that had the equation in it.
Yeah.
Okay. So you're saying you've heard the 3rd law quite a bit.
Yeah.
Okay. Good. All right, Mari, get up. I've always wanted to push you. Ah. Over here.
My teachers weren't supposed to touch students.
Job
Go
is-
back to Mr. Lane.
Okay.
Seriously.
He used to abuse me into wet taxi.
No, Alex.
Okay. So I'm gonna push you, and I want you to just let me push you, like fall backwards, but don't fall down. Okay. All right. So everybody watch.
Okay.
Everybody watch. I'm gonna push him.
He's got the force.
Oh yeah, Mr. Ricky.
What?
Why'd you
Read the book.
Every action produces an equal and opposite
Let's try that
reaction.
again. Now, could I like sit here strong and like lean forward and go like this?
Yeah.
Yeah.
Okay. But if I'm relaxed and I just stand here and push, so I pushed him. He didn't push me. Why did I fall backwards?
Because opposite reaction.
Yeah, believe it or not, he pushed back on me. You know, not from the like. No, you can sit down. Okay. So every action is an equal and opposite reaction. Right now, you all have this happening right now. You guys are sitting in your chair. Okay? Your butt is pushing down the chair. The chair is pushing back on your butt with an equal and opposite magnitude.
Oh.
Okay? How can it be equal? What do you mean? It is. Why can't it be? Okay, so yeah, this is one of those difficult ideas to like.
Process.
Well, okay, it's weird to think of that he pushed, right? Like when we think push, we think like, right? Another example: have you ever like we're in a boat and you like jump to a dock?
No. No.
Yeah.
Okay, what happens to the boat if you don't hold on to it?
Goes backwards.
Yeah.
Go right
It
on.
goes backwards, right? So, but have you ever wondered how you get to the dock?
You push off the boat.
Walk on it.
No, the boat pushes you.
Well,
What?
both ways. You push the boat.
Wait, what?
Push the boat back away.
If you apply a force on the boat, why do you propel forward?
Because
Because the boat is pushing you back.
Oh.
It's trippy, but it's true. Okay, right? Because when you jump off the boat, you're applying a force on the boat. Why would you go forward?
Because that's pushing.
Because that makes you go, "Ah, go crazy, right? Like you've heard this all the time. You're like, yeah, every equal opposite reaction. Blah, 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 blah.
There you go. I like that word.
What, trippy?
Yeah.
That's a nice word. Yeah, like moist.
Yeah.
Okay, so you probably have heard this a bunch, but have you really thought about it? It's more trippy than you might have originally thought. Okay?
I don't think I've ever heard of it.
You never heard of this
I
law?
don't think I've heard of any of the laws really.
No. Huh?
So.
I have.
So here's your example.
Early.
Me?
Oh, come on.
You have to write
You have an action.
You don't have to write this in. This is kind of, if as long as you can have this visual idea. Now, is this the only situation where this happens? No, it's every situation. Okay? When yet? Take a hammer and hit a nail. The nail pushes back on the hammer too. It's weird to think about.
What?
Okay? When a nail goes into wood, the wood pushes back on the nail. It's the way it is. Guys, we know gravity is pulling you downward, right? So that would mean your butt is exerting a force on the chair.
Sorry, chair.
Okay? And the reason why the chair doesn't accelerate downward is because the floor is pushing back up on the chair. Right? Because you think about it, if you have unbalanced force, you would have acceleration. But he's not accelerating. The chair is not accelerating. The ground's not accelerating. So there has to be balanced forces due to Newton's law, equal and opposite reaction. Now, what if the chair was unable to push back up on Ethan as his weight was pulling down? The chair would break. Like imagine like dropping an elephant on this chair.
Are you saying I'm fat?
That's
why
why
you're
you're Skittles.
I'm just trying to butter you up. I mean, when you run, aren't you pushing on the ground? Then why do you move forward? Because the ground's pushing you back.
What?
Oh,
You're moving because the ground is pushing.
I mean, it's not sticking its hands out and pushing you.
Obviously not.
But yes.
So, in basketball,
Uh-huh.
people measure your vertical.
Uh-huh.
So then,
It's not your vertical, is it?
No, so now it's the ground's vertical.
It's not yours.
It's the ground's push.
Well, no. You have to have people who can jump higher push the ground harder.
Okay.
And the ground.
And therefore the ground pushes back harder.
Really just like a push on the ground hard.
Yeah. You gotta push on the ground harder, yep. It's not like, yeah, like that's not.
What?
Yeah, you should go up to Issa and be like, yeah, you can't really jump very high. The ground just pushes you more than it pushes me. Oh, you'd be like, what? What are you talking about? Don't you know? Newton's third law.
Is there only 3?
Yeah.
This is geometry. You have like 30 different laws.
Is this geometry? It's like really different stuff.
Honestly, I think Newton's third law is my favorite
Pretty
because it's the one that you have to kind of think a little bit about. Like the other one's like, yeah, I see that every day. And yeah, do you deal with the third law every day? Yes, but you don't really you don't comprehend it.
Yeah. So even when you're walking this long, just like.
Yeah, every force that there is has a reaction to it, or an opposite force that goes with it. Every force. Okay, that's why it says no force could ever happen if you didn't have an opposite force. Yeah.
The opposite of the electron.
Good question. I don't know. I have to think about that a little bit. Do I teach physics? Yeah. Good. All right. So don't be fooled by the word action reaction, because if you think of the word action, you think of the word reaction, a lot of times you might automatically think movement, like action, movement, you know what I mean, kind of. So Newton's third law just says that there's an equal and opposite reaction force. Doesn't necessarily mean you're moving.
No.
Right, you all right now have Newton's third law acting on you right now, but are you moving? You're not accelerating downward, or the chair isn't pushing you upward. I mean it is, but it's not like causing you to accelerate upward. Okay, so be careful on the words. Also be careful on when I say push, like when the the floor is pushing you back. It's not like it has, like I said, it's not like it has hands that's pushing. Yes.
Alright, so the chair example.
Uh-huh.
The floor is pushing up on the chair, the
Uh-huh.
chair is pushing down on the floor.
Uh-huh.
We're pushing down on the chair, the chair is pushing up on us. How does the chair feel the force itself?
Oh, ground pushing out harder.
You just confused me, like,
What do you mean?
Because the ground is pushing up on the chair is pushing down on the floor.
So the amount that the floor is pushing up on the chair is equal and opposite to the weight of the chair and the force of you down on the chair. Otherwise, it would be accelerating. So the force up that the floor pushes up on the chair is equal to the weight of you and the chair pushing down.
Oh.
Right? Because like it's my mass and the chair's mass that the floor has to push up on, not just the chair. Does that make sense? Okay, so you're probably wondering, well, if the chair's pushing down on the floor, why isn't the floor accelerating? Well, technically, the Earth is accelerating, but very small. The reason why I say that is because the Earth has an outrageously large mass. So it has a lot of what? Inertia. So it resists moving a whole heck of a lot. So technically when you guys run, you are actually accelerating the Earth. But pretty much not. Haven't you ever heard if all the people on the planet went to one area and jumped, would it be enough force to accelerate the Earth that you would feel it? The answer is no. They've actually calculated that. Like if all the human beings in this planet went to one area and jumped, would we have enough mass force to push the Earth? And the answer is no, because the Earth is way more massive still than all of the human beings' mass combined. It's food for thought.
Okay.
Let me see if I want to have you put this in or not. No, you don't have to put this in. This is just like your example that I'm giving you of you guys sitting in the
It
chair.
says baseball in the Bible.
Okay?
It's a baseball. Who said it's softball?
It's moldy, leave him alone.
Okay, guys, fine. Okay, this is just another example of like you guys sitting in the chair or me standing up. Okay, the baseball's weight pushes down on the floor, or it says desktop, I don't know if it's on a desk. And then the desktop resists with an equal and opposite force upwards. Don't put this in. What happened if an elephant were lowered on the desk? The desk would collapse because it would not be able to push up with the same amount of the weight of the elephant pushing down. Yes. You have a question? Oh, I thought you raised your hand. No? Okay. This is why if you walk on thin ice, like if the object doesn't have the ability to have an equal and opposite reaction, it will just break. That makes sense? Like it has to have the ability to push back with the same force. Otherwise it won't, it will just break. Alright? Blow a balloon, the balloon has to push back on the air inside of it. And if it doesn't have enough force to push back on the air inside of it, the balloon will burst. Because the air molecules inside will accelerate right through it. Let me see here. Did you know this?
Yeah.
Did you know this?
Yes.
That's what causes the moon to orbit around the Earth.
I don't think I've ever learned any business. This kind of like.
Yeah. This is why the moon orbits around the Earth, because the attractive forces between the two is equal, and since the moon is less mass, it's going to accelerate more. You can look at it that way. That's a good idea. Yeah, a good way of looking at it. Yeah, I'll agree with that. I'm trying to think if this is something that could appear on a test or a quiz if I wanted you to put it in. No. I just don't want it to like, oh, it's a grammar, each one's not the right or no, so you can't put it on the test. Can I put it on the test if you don't have it in your notes?
No.
I absolutely can.
No, you
No.
can't.
'Cause I bet you it's in your reading, and you're required to do your reading.
Okay, well, that's
No, don't put it in your notes.
Ah, see.
Don't put this in your notes either. This is to me the craziest of all that I've talked to you about Newton's third law. So rockets utilize the principle of Newton's third law as well. So hot gas exerts a force downward from the rocket. So the rocket shoots out hot gas. Well, guess what? Sorry, what's a better way of phrasing that?
To be honest, I did not think of it that way until everyone started.
Okay, yeah. So the hot out.
Hey, Trevor, it is not that bad. We were in drama.
Oh yeah.
Word, bro.
This is physics.
I almost had a real bad mistake there.
Yeah.
On camera.
Yeah.
It's okay. We're in drama. This is-
The hot gas accelerates downwards. Okay? Believe it or not, the rocket gets propelled upward because the air molecules push it. Not like that.
No.
Okay? So gas pushes down, the air molecules get pushed by the gas, and they push back equal and opposite, which causes the thrust of the rocket to go up. Do you think the gas had the capability of pushing a rocket up through into the air? That's crazy. That's crazy. Yeah.
Are you saying it's rubber?
That could have been a very bad effort.
What was he about to say?
I had to say
Hey,
Don't leave.
Alright. Oh my gosh, you reminded me of
I'll just read you if you want. What are you saying, Mario? I can't get the
I remember that because Isa accidentally said it during the performance. The problem is we got a recording of me, and since I was directly after my
I
line,
stopped myself. I thought I actually.
Oh, seriously?
no, but it was
I was like, did I start to say it?
Yes,
didn't say that.
you almost completed it.
Good. Okay, I thought I legitimately said it there for a second.
You said it.
I didn't. That would have been real bad. I'll have to check. I'll check on here to make sure. I can't upload it, but you know, if I said that.
I don't remember. I don't care.
Wow, so demanding. Oh!
Worksheet. Yeah, and
What's your question? You were asking me something or stating something. Yeah, because I kind of ignored you because I